Welcome to Xamarin University and XAM320, Design an MVVM view model in Xamarin.Forms. We have three objectives we're going to cover today. First, we'll talk about the model view model design pattern, its origin, and the basic usage with Xamarin.Forms. And we'll talk about how to manage visual behaviors, where our logic needs to change things visually on the screen. Next, we'll talk about how to add action behaviors into our applications using commands. Then finally, we'll talk about testing our view model code with unit testing frameworks. A popular UI pattern, which has evolved over the past few years, is the model view model pattern, or MVVM. And this has become particularly important in the XAML or data binding world of WPF and Silverlight and Windows Phone and UWP. And as we talk about in our XAM301 class, which is our mobile application architecture, MVVM relies explicitly on a data binding engine to provide the data for the view. And this replaces the controller or the presenter that's used in MVC or MVP patterns. MVVM has three layers. There is the model, which is your data or your entities or your business logic, the view, which is the presentation on the screen, and the view model, which sits between the model and the view. And this pattern is deliberately layered. The view model knows about the model, and the view knows about the view model, but the view model should not know about the view, and the model should not depend on the view model. Now, because MVVM will require some infrastructure, there are a lot of great libraries out there that provide the basic requirements and more. Here on the screen, you can see a list of some of the popular choices that work with Xamarin. And this is by no means a complete list. You might have a particular favorite that's not listed, and it wasn't meant as a slight. There's just too many to list. Now, in this course today, we'll be managing the MVVM infrastructure ourselves. But once you learn the patterns, you might decide to use an established framework. The next thing we're going to discuss is how to control the visual behavior of the application. For example, dealing with selection and varying the UI based on the data. And we have a few things to discuss here. First, we're going to compare the view and the view model responsibilities. And then we'll talk about selection management with MVVM. And finally, how to react and control the visual state through changes in properties. Now, one of the most confusing parts about MVVM for beginners to the pattern is what goes where? Well, the view model is intended to help the view do its job, and as such is tied directly to the view and its behavior. However, the view model is not supposed to be visual in nature. It should, in theory, be usable with any view technology. For example, we could use a view model with a native iOS application using MVVM Cross, for example. Or we could take that same view model and use it in a WPF desktop application. So the view model supports the view, but it is intentionally unaware of the UI that drives the view. For this also means it has no dependencies on Xamarin iOS or Xamarin Android or Xamarin.Forms. Also, remember that MVVM pattern is a layered pattern, so the view knows about the view model, but the reverse is not true. The view model should have no idea about the view. Now, one of these tricky areas is managing selection and activation, either of which drives detail screens or sometimes navigation. And selection actually tends to be one of the more complicated parts of any application that manages lists of data. Changing the active selection usually affects other UI elements, and when dealing with multiple pages, we often want selection to be passed around and maintained when we navigate backwards. Well, in MVVM, the preferred way to manage selection is to take advantage of two-way bindings. So here on the screen, we're using a list view to display our collection of employees, and that's exposed from the view model through an employees property. We then can add another public property on the view model named selected employee and data bind the list view's selected item property with a two-way binding. This means that when the list view changes the selection due to a tap from the user, the property will be changed in the view model. And if the view model changes the property value, then the selection state of the list view will be altered. Let's look at the implementation of the property. The main view model is our binding context, and it would have a collection of employees. The selected employee property would raise a property change notification anytime the property is altered. This allows the view model to initialize the view with a known selection state. And notice that all of this code drives the view, but it's not UI-centric. In other words, we could unit test this code. Another thing that we'd like to manage in our view models is the visual state of our application. So let's take a simple example here. Say that we'd like to use color to identify the role of an employee. Maybe we use gray to indicate a normal employee and blue to indicate a supervisor. Well, one way that we could accomplish this is to put a name color property into the ViewModel. Then the ViewModel could just identify the proper color based on its existing knowledge about the model data. Well, the problem with this approach, though, is that color is a UI-specific property type. And we'd like to avoid this because, first of all, it ties our ViewModel to Xamarin.Forms, which makes it harder to unit test and harder to reuse if we ever decide to move to a different UI platform with this code, but also because color is still a view responsibility. So, for example, we could change the property to just use a string. So we create a name color property, and we use a string color to designate the proper color. And then we could rely on a built-in converter to take our string and translate it to a color property. And that is a better approach, but it's still really not ideal because we're still defining visual properties in our code. And visual properties are things that we really should be defining in the view. So what we'd really like to do is just to have a simple Boolean property in our ViewModel, or an enumeration property that indicates the role of this employee, and then have the color change in the view based on the value of that property. We could use a value converter to do this exact thing, and that's certainly a valid solution, but it turns out there is a better way to do this in Xamarin.Forms. Let's start by defining a Boolean property indicating the business requirement that we have. And we said that we want the color of the name to be based on whether they're a supervisor. So we'll create a Boolean indicating whether they have subordinates in the organization. Then we can take advantage of a feature in Xamarin.Forms called triggers. Triggers allow you to change a visual property value based on the state of another visual property. And there's a special type of trigger called a data trigger that allows us to do this with a data binding. So here's how this works. We define a label in our code to display the name. We then set a default value for the property in question, in this case the color, and we're going to set it to gray. Next, we add a triggers collection to the label. We can add 0 or more triggers to any UI element. In that triggers collection, we will add a single data trigger, which is applied to the label type. The target type property is required, and it identifies the specific element type that the data trigger is working with. The data trigger has a binding set to our property in the ViewModel. So in this case, here we're watching a property named supervisor. Next, we provide a comparison value for the binding. Here we're going to watch the isSupervisor property and wait until the value is true. And this, of course, requires that the property do the normal property change notification so that the binding can see the changes when they happen at runtime. Then finally, we add one or more setters to the trigger. And these are property setters that are applied when the binding comparison is successful. So in other words, when the isSupervisor property is true, then we want to change the text color property on the label to be blue. If that property evaluation fails and the isSupervisor is false, then the label uses the default applied value, which is gray. Now, data triggers require an equality condition, and there's no support for more complex mathematical tests. Often we can resolve this through properties in the ViewModel that return Boolean values so that we can definitively test for true or false. Another option would be to use value converters. These are interface implementations that are used to coerce or change a type for the UI. And we use them a lot when we're relying on the MVC or the MVP approach, and we're data binding right to a model, because the model usually isn't in quite the shape or the form that we need for the UI display. Well, in MVVM, we don't use value converters quite as much. The ViewModel can expose properties that have this conversion logic already built in, which reduces our need for many of the UI-specific value converters that we might otherwise use. However, they do still have a place. You're going to find yourself building a library of useful primitive converters, things like a not Boolean converter, or this double to integer converter, things like that. And there are a lot of them out there on GitHub that you can use and on NuGet. Now, MVVM is often talked about as something magical. It's going to solve all your problems in your application architecture. Well, it is a great pattern for many applications, but really it's just one of many that you'll likely take advantage of in your application design. Other common design patterns, like dependency injection, the factory pattern, singleton pattern, and the commanding pattern, are all very common in MVVM applications. You don't have to use these other patterns. We just tend to find that they work very well together to provide the overall application structure. Also, MVVM is an architectural style, so it doesn't really mandate how to implement common features in your application. So you're going to find that you need to abstract out features like navigation and UI prompts and message passing to connect components together in a loosely coupled fashion to use them in your view models. Making those features accessible to your view models is where we often use factories and singletons and dependency injection patterns. Let's take a look at a couple of examples. Navigation is one of the first trouble areas people run into with MVVM. And as you can imagine, there's a million different ways to solve this problem. We don't want to reference the Xamarin.Forms page class in our view models because that would tie us to Xamarin.Forms. But the navigation APIs in Xamarin.Forms are based on the page class. And the navigation APIs generally reference view-specific things. So this will require an abstraction. A simple way to manage this is to create a specific navigation service that has methods to display different screens. And it has knowledge of the screens, and therefore it can use the platform APIs, but it exposes those methods in a platform-agnostic way so that we can mock the service out for testing and we can replace it for different platforms. You can see an example of this here. The view model would get access to this service in some way, perhaps through a singleton property, through dependency injection, or through Xamarin.Forms built-in dependency service. And then the view model would invoke the APIs to move to a specific screen or to move backwards. More complete MVVM libraries and frameworks often define special attributes and high-level navigation services to make that more generic. So definitely check out the other frameworks and see how they manage navigation. Now sometimes we need to notify activity to different parts of our application. We could use traditional events for this, and if the two pieces of code are related, an event might be the solution. But sometimes we want to notify other parts of the application that don't have a direct relationship beyond both being interested in a piece of data. If the two components share a view model, we could use a property notification. That's often the case in selection, for example. But if they're completely unrelated classes and they don't share a view model or anything else, then we have to find some way to provide loosely coupled notifications. Well, in those cases, we often use design patterns like message mediator or message bus. Again, third-party MVVM libraries almost always have a component that does this. We also have one built into Xamarin.Forms that we can take advantage of. It's called Messaging Center. This is specific to Xamarin.Forms, but is easily replaced with a platform-agnostic messaging system as well. So here's how this works. First, we have publishers and we have subscribers. The publisher is the entity that sends the message. The message is sent to the Messaging Center along with a string-based message to identify the targets for the message called the subscribers. The message goes to the Messaging Center and it looks up interested subscribers based on the passed-in key. It then calls each subscriber and it passes them the message data. To publish a message using the Messaging Center, you call the send method. This is a generic method and it takes either one or two parameters. It always has to include the sender type. Here you can see that's the main view model type. This has to match the first parameter passed to the method. So we're assuming that the this keyword is a main view model in this case. The second generic type is the message parameter. This is optional. You can leave this off if you have no other parameters to pass along with the message, if the receipt of the message is enough to trigger your code. Then we pass 2 or 3 parameters to the send method. The sender object, the string message key, and the optional parameter, which has to match the parameter type specified. Then on the subscriber side, we need to use the subscribe method to hook into a message. Again, we use a parameterized version with the expected sender type and the parameter type, which again is optional and can be left off if there are no expected parameters. The method is passed the instance that will handle the message. This can't be null. It's also passed the string message key, and this has to match the string being used by the publisher. And finally, it's passed a delegate handler, which receives the sender and the optional parameter. This handler will be called when the send method is used by the publisher. The message is identified by the type of the sender, the message key, and the parameter type. All 3 of these have to match in order for the message to be delivered. Also, the string message key, select in this case, is case sensitive. So mismatching case would cause this not to be delivered. Now this is really a bare bones messaging platform. The publisher type needs to be known in order to subscribe, And a lot of messaging systems don't require that, and it makes messaging a little more tightly coupled than you might find in other implementations, but definitely check out the other implementations in the other frameworks as well. And now it's time for you to work on an exercise. Open up the worksheet that you downloaded as part of the lab materials for this class. Work on the driving behavior through properties exercise. Pause this video and come back when you're done. So now we've seen how we can control and activate events with selection and use properties and triggers to manage the visual state. Next, let's look at another aspect of behavior, when we have an action to perform as the result of the user interacting with the UI. We have several things to discuss here. First, we're going to introduce a new concept into the mix, the command pattern. Then we're going to look at how the command pattern is implemented in Xamarin.Forms and talk about how to generalize that pattern to make it easier to work with. So as you might have noticed, we still have some untestable code in our code behind here. Specifically code to manage UI behavior. What should happen when the user taps a button? Well, often that code is fairly minimal and is perfectly acceptable to have that in place. Well, sometimes, however, you might have a lot of interactive elements, or you just want to push the behaviors into your view models so that they can be shared and tested. And that's what the command pattern is all about. The command pattern is an abstraction pattern to decouple an action from a behavior. This is commonly used in UI platforms that have multiple ways to execute a task. For example, consider a typical desktop application like Microsoft Office. There could be a ribbon UI with buttons. There could be shortcut keyboard gestures. There could be context menus using the mouse. Rather than having separate event handlers that all end up executing the same logic, we can use commands. The UI element points to the command, and then the command in turn points to the behavior. So in this way, we can tie multiple input mechanisms to the same command, and we get the same behavior in response without having to rewrite that code. Microsoft formalized this pattern for WPF with the iCommand interface. This has two methods and an event. So the can_execute is called by the UI element to determine if the command is valid at that moment in time. In platforms that support this directly, the response will influence the visual state of the control. For example, buttons will be disabled when the can_execute returns false. The execute method is called to actually run the corresponding logic. And then finally, the can_execute changed event should be invoked when the command validity has changed. This tells the system to update its state by calling can_execute again for the given command. Now, commands are baked into the Xamarin.Forms platform. Several controls actually provide the ability to invoke commands when they're activated in the UI. Things like the button, which is the most common active UI element that we use. The menu is used in pop-up menus. The toolbar item is used in the toolbar. The text cell is used in list views and table views. And there's others as well. We use commands by creating a public property in the view model of type iCommand. It only needs a getter because the UI never sets a command. And then we bind to this property from a supported UI element. So for example, here we bind the give bonus command to a button in the UI. When the button is tapped, it will invoke the command in our view model to execute the logic. You can also still wire up the traditional event as well, like the clicked event in this case. Adding a command handler like this does not impact the raising of the event. And you can add logic into both if you'd like to handle the button tap in your view model and in your code behind. For other controls that don't explicitly support a command property, you can use a tap gesture recognizer to invoke a command when the control is tapped. For example, here we included an image in our UI, but the image control doesn't have a clicked event. But we allow the tapped interaction with the image to call out to a command exposed on the view model. You might recall from the interface that all the commands have a parameter that can be passed in. We supply this optional parameter, which defaults to null, using the command parameter property. In this case, we're simply supplying a string to the parameter, but you could use the property element XAML syntax to create any object that you need. Or you could even use a binding to supply the value from a UI element or some other property. And then when we define commands in our view model, we have a couple of approaches that we can take. The command simply needs to implement the iCommand interface in order to be valid. So one approach would be to create a dedicated class that implements this interface, and then instantiate that class in our view model and provide access to it through a public property. We would then follow the same pattern for all the other commands in our app. Create a unique command for each behavior that we want to encapsulate. When we're creating this implementation, we have these three required member implementations we need to provide. So we have the can_execute, the execute, and then the event handler. So here's an example of a command implementation. And notice how most of the non-boilerplate code is actually dependent on the ViewModel data. And that's very common with commands. Most of the time, they don't have all of the state information necessary to make decisions, and they have to access our ViewModels where that state is actually available. So is there a way to move this logic into the ViewModel? Well, one way that we can generalize this code is to use a wrapper that implements iCommand, and it forwards the calls to the execute and the can execute using delegates. This approach is often referred to as a delegate command or a relay command. Xamarin.Forms includes an implementation of this in the command and the command of type T patterns. The idea is to create two delegates, one for the can execute and one for the execute, and then forward the logic from the interface to the methods that are in your ViewModel. You can see an example of how this is implemented in this code here. In the Xamarin.Forms implementations, the command passes the parameter as a base object type, or you can also supply just a plain action with no parameter, and in that case the command simply ignores the parameter. The command of type T version performs an explicit cast, as you can see here in the slide, and that means the passing parameter has to conform to the given type of T. Now with this approach, we can define any number of delegates with the same class and consolidate all of that testable logic back into the ViewModels instead of scattering it throughout all the commands. So in this code here, we use the command type and we handed a delegate to the onGiveBonus method to use for the execute logic, and a delegate to the onCanGiveBonus method for the can execute logic. Notice that since we don't need the command parameter, we just leave that off the definition. The command class will simply not pass it along. Although if we did need it, we could define it as an object type, or use a command of type T to cast it for us. So now, go back to your worksheet, work on the using commands to run behavior exercise, pause this video, and come back when that's complete. We've now seen how we can implement the iCommand pattern in our ViewModels. Now the final topic we want to briefly touch on is testing. We aren't going to go into all the mechanics of unit testing. We have a full class on unit testing that you can view for all of those details, but it is helpful to see what can and can't be unit tested easily in a properly architected MVVM application. So let's jump into it. When you're creating unit tests for your mobile apps, you're typically restricted to things that are not UI dependent. So in other words, the testable code is the code that can be executed independent of a UI platform. And that's exactly what we've been building with ViewModels and models. Code that is view-centric, but is not dependent on a UI technology. As such, you have two areas that lend themselves very nicely to unit tests: ViewModels and models. Keep in mind, we're just talking about unit testing. There are other important types of testing that you should also be doing. One of the benefits of MVVM is the intention to be able to unit test. The ViewModels are intended to be the view's representation of the data, but they're not visual. They should always be completely unit testable without requiring a UI. This allows for testing of business logic and visual logic. And now using commands, you have visual validation and state, things like selection in the ViewModel layer that can be tested independent of the UI. That allows you to validate the requirements for your application in a platform agnostic way, and then reuse that logic across different platforms. And you can use any well-known unit testing framework, like NUnit or MSTest or XUnit. So here's an example where we are testing our employee ViewModel with the GiveBonus command. We pass in $500 as a string, and then we go retrieve the next paycheck, and we verify that the $500 has been applied to the extras field. And as you can see, our tests have intimate knowledge of the working and the relationships of the classes, and they can even test fairly complex bits of logic. Again, our intention here is not to walk through all the details of a unit test, just to show you how you might apply it to your ViewModels. Thank you for watching Xamarin University's video on implementing Model View ViewModel in your Xamarin.Forms applications.